Modern physics is built on two completely incompatible pillars. General relativity maps the massive scale of the universe, dictating how gravity guides planets and stars. On the other end, quantum mechanics precisely governs the erratic behavior of subatomic particles. These models work flawlessly in their own domains, but they collide violently in extreme environments where immense mass is crammed into a microscopic space, such as the singularity at the center of a black hole, or the exact moment the Big Bang occurred. This data visualization shows exactly where the math falls apart. When calculating the gravitational pull between two microscopic, zero-dimensional point particles, the interaction curve shoots straight up as the distance shrinks to zero. The result is absolute infinity. In theoretical physics, an infinite answer means the equation is entirely broken. It proves we are missing a critical bridge to connect the massive with the microscopic, a working theory of quantum gravity. Until we resolve these infinite mathematical errors, our understanding of how reality operates at its most extreme limits will remain completely blocked. The proposed cure starts by deleting the point particle entirely. Instead of a zero-dimensional dot, physicists replace it with a one-dimensional vibrating string of energy. Just as different vibrations on a guitar string produce different musical notes, the specific frequencies, twists, and folds of these microscopic strings produce all known subatomic particles. Crucially, this includes the graviton, the theoretical particle responsible for carrying gravitational force. Because a string possesses actual physical length, it prevents particles from ever reaching a distance of absolute zero. It smears out their interactions over a tiny area of space, which successfully stops the math from exploding into infinity. But this mathematical cure comes with a bizarre cost. For the equations governing these strings to remain consistent, our standard reality of 3 spatial dimensions and 1 of time is simply not enough. The math strictly demands a universe with 9, 10, or even 11 dimensions. To explain why we don't experience a 10-dimensional world, the theory relies on compactification. The extra spatial directions are tightly curled up into complex microscopic shapes, hiding at every point in space, far too small for our tools to detect. String theory flawlessly cures the infinite errors of quantum gravity. The trade-off is that we have to accept a hyperdimensional reality existing entirely beyond our sight. This strange hyperdimensional math proved uniquely capable of solving impossible physical puzzles. Consider Stephen Hawking's information paradox. Hawking proved that black holes eventually evaporate, which seemingly destroyed the quantum information of anything that fell inside. This direct violation of the core laws of physics stumped scientists for decades. In 1997, physicist Juan Maldacena found a workaround using string theory, developing the ADS-CFT correspondence. He discovered that 5-dimensional quantum gravity inside a black hole could be mathematically mapped onto a flat 4-dimensional boundary, making previously impossible calculations solvable. This mapping revealed that the quantum information swallowed by a black hole is never actually lost. Instead, it is encoded directly onto the 2-dimensional surface of the event horizon, much like a hologram. The holographic principle proves that string theory provides a functioning mathematical toolkit to resolve paradoxes where standard physics fails entirely. Despite resolving these massive paradoxes, severe scientific skepticism persists because we lack direct physical evidence. Our current tools, like massive circular particle colliders, are nowhere near powerful enough to detect strings at their microscopic scale. A 2026 study from NYU and Caltech researchers took a completely different approach. Instead of trying to smash particles together, they utilized a mathematical technique known as the bootstrap method. The researchers intentionally stripped away all the complex equations of string theory. They started out with just 2 undeniable assumptions about how particles naturally scatter off each other at extreme energies, and let the math play out naturally from there. From those 2 basic constraints alone, the exact, precise architecture of string theory automatically emerged from their equations. The math independently generated the precise masses and spins of string theory particles. The researchers didn't plug these numbers in as a guess. they appear dynamically as the only possible logical solution to the scattering problem. This demonstrates that string theory is a mathematical inevitability. A universe built out of tiny, vibrating strings appears to be the only logically consistent way a cosmos can contain both gravity and atoms.